With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so we are given with a question which says figure shows a conducting loop ABCDA placed in uniform magnetic field of strength B perpendicular to the plane. The part ABC, that is 3/4 portion of the square of side length L. The part ADC is a circular arc of radius capital R. Point A and C are connected to a battery which supplies a current I to the circuit. The magnetic force on the loop due to the field B is. So before starting, I would like to recall few important points regarding a loop that has been placed in a magnetic field. Let's suppose first importantly, let's suppose in a magnetic field, let's say this is a magnetic field over here, and in this magnetic field a current carrying uh, rod we can say is placed. Alright, so this is a rod which is carrying a current and this is placed in a magnetic field. So we can say this rod will experience a force. So let's suppose that if the rod length is L and current which is been flowing downward is I, so we can write the force that has been acting on this can be written as I L cross B. Alright, so in terms of vector we have written it over here. So L bar cross B bar. So this is nothing but the angle between L bar and uh, magnetic field vector. So this is the force that has been acting on the conductor, current carrying conductor placed in magnetic field. Second important case is in a magnetic field, when we place a closed loop carrying current, let's suppose that this is a magnetic field and this in this magnetic field we have placed a closed current carrying loop. So the force acting on this loop will be 0. Alright, so the force acting on this loop will be 0. So now using these 2 points we will try to answer this question. So as we can see, this is a loop. As we can see, this is a loop, but we have to be careful that this is a complete loop which is carrying a current I in it. Now in this section, in this our case, there are 2 points, that is A and C, alright, which is connected to a battery source, and due to which let's say current I is flowing over here. So let's say it gets divided over here and I2 over here, so it gets divided. So 2 different separate currents is been flowing in the circuit. So we cannot say the force acting on this loop is 0. Alright, so I hope you are getting this point. And secondly, one more important point which we have studied, let's take it as third point. So let's say if in a magnetic field an open loop is been placed, for example let's say semicircular arc is been placed, and if we wish to find the force on this, so and let's suppose the radius, this semicircular arc is having a radius of small r. So we can say the force acting in this case can be written as F equals to, in terms of magnitude I am writing, let's say magnetic field is B over here, so IB, and distance between the 2 points, so we have to take the length as distance between the 2 points, that is 2r. So this is the case. Alright, so these are 3 different cases. So now we will try to answer this question. Now as we can see, for ABC we can say, let's take it over here. Now for loop part ABC, alright, so in this we can say the force acting on a square section, so we can take force acting on square section can be given as I1 into length has been given as L and magnetic field is B. So this is the value, and sine theta is 1, so we are taking just magnitude over here, so IB I1 LB. Similarly for loop part A, D and C, let's say the force acting on the circular part can be given as I2. L here can be written as, again we can see the distance between A and C for the square loop and for circular loop is the same. So we will again put L over here and into B. Alright, so these are the two forces. We can say, therefore, let's say this is our equation number 1, this is our equation number 2. So therefore from 1 and 2, we can say net magnetic field can be written as, or we can say, sorry, net force on the loop can be written as FC plus of Fs. We are not going into the direction, we are just trying to calculate its magnitude. So we can write I1 plus I2 can be taken out as common, so we are left with this, and we know since I1 plus I2 is I only, so the net force we are getting on the loop is ILB, and here we will give the reason since I equals to I1 plus I2. Alright, so this is the answer to this question, and this matches with option B. So I hope you have understood the concept, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.